bit similar to that first problem on the quiz. Quotient rule should never be my go-to. Like, one, there's no result of a quotient rule, right? There is no quotient rule for going backwards and finding anti-derivative. So it would be, I must have had some function where I applied the quotient rule and I got this. Why do I rule that one? Actually, it's not quite obvious. If I did, my bottom function would have to x, right? So there's a chance I could get it that way, treat the bottom function as x, or the top function do. That's a little harder to do. As we can see right here. Bottom times the top minus the top function times the derivative bottom. Derivative bottom is 2x, means my top function must have been 1. My top function is 1, so I get a 3 here. Bottom times derivative top would have been 0. This can't be a quotient. Usually that's not our go-to, but even here if you tried it, it would break down. Another one I saw that was fun was people taking antiderivative top, antiderivative bottom, and pretending products and quotient rules and all those things were never a thing. If you just randomly take antiderivatives in places and you're still like multiplying and adding and dividing, always think of that as a red error. Always hesitate to do that. Ask yourself if that's really allowed. If it's not allowed when taking derivatives, it's definitely not allowed when going backwards. Right? So, what would I do?
Split it into 3 over x squared minus 2x over x.
Yeah, I'd rewrite this problem this way. And then why would I do that? What is this first one going to be? It's going to be the definite integral of 3x to the negative 2. And this other one is going to be the definite integral of x over x squared, so x to the negative 1 or 1 over x. I'm going to put it outside. So then what is the antiderivative of x to the negative 2? Why did I rewrite it this way? So I use the power rule. I really always want to use the power rule if at all possible. The only time I don't do the power rule, and this is what I saw in the quiz, is we did the power rule for the top and the power rule for the bottom. You definitely can't do that. Like, that's why we have the quotient product rule and all these other rules going for derivatives. So just remember, if you're doing that, it's not that nice. So, what would I get? This is the one that's easy to mess up. When you add 1, you get negative 1, right? You get a lot of negatives for you. Negative 2 plus 1 is negative 1, so I'd end up with negative x to the negative 1. Then what about this one? What is the antiderivative of 1 over x?
ln.
ln of x, that's one of the special ones, right? And I'd also evaluate that one from 1 to 4. So I end up with 3 times negative 1 over 4 plus 1 over 1 minus 2 times natural log of 4 minus natural log of 1. So what is that? 3 times 1 minus a fourth is 3/4. Minus 2 times, what's natural log of 1? 0. So 2 times natural log of 4. End up with 9/4 minus 2 natural log of 4. And it doesn't have to be a pretty number, that's fine. Questions on that? what could I have done to make sure I didn't make a mistake? In this step, I could have said, what is the derivative of negative 3x to negative 1 minus 2 natural log of x? Right? So I get negative 3 times negative 1, x to negative 2, minus 2 divided by x. So 3 over x squared minus 2 over x. Does that check? We want to get a common base, it would be x squared. So 3 minus 2x. Remember, you can always go back and check. And really, I recommend checking every time, just, it's how you catch mistakes. And it's how you remember to do the power rule correctly. If you messed up the power rule going one way, you're less likely to mess it up both ways and have it magically check. Okay. Any other questions on that one? Great. So that's the sign area. What is the one difference when I try to do absolute area?
You could divide the intervals into positive and negative.
Yes, and when I go to solve it, yes. At a high level, all I'm doing is putting absolute value in it, right? Signed area means my integrands have been positive sometimes, negative other times, subtract. That's fine, I'm getting a net signed area. When I do absolute area, I only want to count positive things. So to do that, I put absolute value on it. And then, all right, in some ways it's easy to write the formula, but then using the formula is less easy. To use it, I really need to get rid of the absolute value. We didn't have any derivatives where your derivative randomly had an absolute value, right? Technically, there's one that had an inverse secant. That doesn't look like inverse secant derivative. No. Yeah. So, like, absolute value shouldn't just randomly appear, so we need to get rid of it first. Then we can probably do things we know how to do. So how do I get rid of absolute value?
Split it into two different intervals.
Split intervals, maybe 2, maybe 3. Depends on how many I am. It'll be 2 on this one. But I need to know when is it positive, when is it negative, right? Because if it was negative, absolute value suddenly changed the problem and make it positive. So I need to know basically when did absolute value actually do something. So if I want to do that, I want to know when was this. I really just want to normalize this. When is it positive, when is it negative? So when is it undefined? When x is equal to 0. When is it 0? When the top's equal to 0? So I get this number one. And then I want to do test values. Where do I need test values?
Is the left and right of 3 over 2? The other one.
Yeah. Yep. Now I look at it and say, technically, I only care about 1 to 4, right? So when I do test values, I'm going to pick them between 1 and 4. So, although this says I could just plug in 1, doesn't it? So what happens if and I'm going to plug in 1. If I do a fraction between 1 and 3 halves, that's more effort than I want to do. You can do something like 5/4 like this. But what do I do? 3 minus 2 over 1 over 1 squared, I get what? 1 over 1, positive. If it's positive at 1, it's technically positive for all those. Why do I know that?
Because it would have a sign change.
Yeah, my sign can only change at 0 or 3 halves. So, like, think back in chapter 3, the only numbers that matter is 0 and 3 halves. Whatever happens lines for all of them. The fact that I'm using one here doesn't really matter in some sense, does it? Like, I could do a number line for only one tool. But I could also use one as a test value to find this out. Because the only ones that matter is 0 and 3 halves. So what do I do bigger than 3 halves? 3 is easy plug in, or 2 is easy plug in, right? Can I get a negative number? So I know I'm positive initially, and then I switch to negative. So then, how do I get rid of my absolute value? Why did I take a detour over there? If my function is positive, do I need the absolute value? No. So when am I positive? I'm positive from 1 to 3 halves. And on that interval, I can just do this, right? Absolute value doesn't do anything. That's the same as having an absolute value. And then what about for this interval? When I go from 3 halves to 4. Now I had a negative number, right? Or I know my integrand's negative. Or sorry, I know 3 minus 2x is negative. So if I want to make this positive, what do I do? Scale it by -1. So were those equal? One above and one below? Okay, I want to get rid of absolute value. What does absolute value do? On this interval, it does nothing. On this interval, it took my negative number and multiplied by -1, make it positive. So I get this. Some of y'all really do not like writing DX. I learned that on the quiz and homework. What's the convenient thing on this?
We already found the integral.
The integrand's always the same thing, right? I either put a plus or minus in front. I already know the antiderivative of this, or what the antiderivative would look like, or an antiderivative, I guess. So this first one would be what? So I did all this work really just to get to here, right? Or I can look here. This was my antiderivative. What is it the antiderivative of? This integrand? Or this function? So I can do what? -3 over x minus 2 natural log of x, evaluated from 1 to 3 halves, and then subtract, and it's the same function. But now I evaluate from 3 halves to 4. I'll circle that. Basically, this says if I want to integrate this, I would get this function. Because the derivative of this function is exactly this integrand, or this one. Alright, now what? Plug in and subtract. You don't really want to see all that? Plug in and subtract. I will get 4 natural log of 4/3. Minus 1/4. I'm posting the solutions after class. So if you want to see the half page of plugging this in and doing arithmetic, that will definitely be available. What do I notice? Which one should be bigger? This one or this one?
Absolute value.
Yeah, the absolute area has to be bigger. Nothing could be subtracted while I did that. So this one would be about 0.9. And if I check, the other one is about negative 0.5. The second time, when I do absolute value, it has to be bigger, right? When I'm adding up everything, all the areas, I'm only adding, I'm never subtracting anything. Whereas this one, it says this function was actually below the x-axis more than it was above it, which is why this sign area is negative. In the solutions I post, I have the full picture, everything to illustrate what's happening. A lot of these, you're not expected to draw a graph unless the directions say draw a graph. You don't always like to follow the directions on homework. This book's good about giving directions that are like a paragraph long. So then you forget what you're supposed to be doing. But a lot of these problems, it says at the end, draw the graph. This one, I don't think it does. Alright, but if you look at the posted solutions when I post those after class, it'll have everything drawn out, kind of label everything so you can see it better. Any questions on that? These take a long time to do one problem. And it's not that it's necessarily hard, it's tedious. So, never let yourself think tedious means hard. How do you do tedious? Know it's going to take a long time and accept that and just go slowly and make sure you don't make a mistake. What makes tedious hard is if you ever make a mistake in the middle. Then you have this much work and you don't want to find your mistake. So tedious, go slower and check every line as you're going, and then you know it's good. Right. The trick to tedious is you don't want to do it twice. What's the one part of this that would have been easy to really mess up is finding the antiderivative. And that's the one you can always check right after you find it, right? It's like you know whether you got that part right or not before you do way too many other things. Alright, number 2. Find the area bounded by f of x equal 2 sine of x. And g of x is equal to 2 cosine of x. On the interval, what interval do you think you're going to use? You always pick the same one the first time.
In terms of pi.
Well, yeah. We always do like 0 to pi, 0 to pi over 4. Yeah, we're not doing that. Pi over 4 to 9 pi over 4. Let's make it look random. We never do trig functions on this interval. Alright. So, technically, this is the formula we're not going to use. According to your book, all you have to do is solve this. Which is a true mathematical formula. This holds. it is not helpful in the least. You really want to picture and to really look at this and see what's happening. Alright, so we could do that, but then you have to go to the absolute value, right? And suddenly that becomes much more involved. Instead, let's draw a picture. So 2 sine of x. What's sine of x do?
Starts at the origin and then goes up and goes back down at pi.
Yeah. So if I call this pi over 4, that would be pi. So this is 2 pi, which means this is 9 pi over 4. Right? So what happens? Sine of x starts at the origin. When do I hit 1? Pi over 2. And it goes back to 0. Then it goes down, goes back up. And then what's the value of 9 pi over 4?
Square root of 2.
Yeah.
Over.
This is 9 pi over 4. How do you get there? Go all the way around once and then hit here. So what are the xy coordinates? This one is root 2 over 2, root 2 over 2. So if this one is going to be root 2 over 2 times 2, so it's going to be root 2, which will just stay right there. So it does this. Alright, so that's f of x. What's the difference with g of x? G of x starts at the amplitude. G of x is going to start here, and then do what? Go down to here, go back up to the top, and then it's going to hit 9 pi over 4 at the same place. At this angle, they're the same value, true? So it's going to go like this. And then it said find the area. So we were looking at find the area from pi over 4 to 9 pi over 4. So this is my interval A to B. So what happens on the picture? That's exactly when they intersect, which that was bad drawing. So I want to find what is the area that's shaded. So I had my formula. I don't really want to use that formula. What am I going to do now?
Split it into 2 different integrals with the functions being on top times.
So I can probably guess what this angle is. I do need to know this. Why do I care about what this point is? What happens here? Which function is bigger? So really it's always, what I'm thinking is if I want to find area bounded by 2 things, I want to integrate top minus bottom. Top minus bottom is always positive. So then what's going to happen at first? When I start at pi over 4, and I'm going to go up to some number I haven't found yet, which is my top function. Yeah, f of x. So my top function is the black curve. So I would do f of x minus g of x. And then I'm gonna take the integral from c to 9 pi over 4. And now what's my top function? Now the red curve is on top, which is g of x. So cosine of x started up here. So now cosine of x is the bigger one. So it's going to be g of x minus f of x. So I can get rid of absolute value when I think of it as top minus bottom. But then that changes on each interval, right? From here to here, one function's on top. I don't know, that point is x coordinate c, the way I wrote this. And then from this interval, starting at the number c up to my right endpoint, the other function's on top. I see why you said two intervals. There's always two intervals when I do an example. One of these days, I'm going to make it cross twice. So I can get rid of absolute value if I just know top minus bottom. But to do top minus bottom, I need to know what are the intervals where one is on top of the other, what are the other intervals in case it switch. What is left to finish setting up my formula? Yeah, I need to show c is 5 pi over 4. How do we know it's 5 pi over 4?
Because that's the other value where the sine and cosine are equal.
So I need f of x equal g of x, so 2 sine of x, 2 cosine of x. So sine of x equal to cosine of x. When does that happen on the unit circle? Here and here? Here's an awesome way I like to do this. This represents an x coordinate, right? Cosine is an x coordinate, sine is a y coordinate. Graph the line y equal x on top of the graph of the unit circle. They intersect twice, right? Where they intersect tells me the angles I care about. I don't know if anybody teaches it this way. I used to. Alright, so what points are these? The y coordinate is the x coordinate. It must be at these 2 points. So what angle would that be? I would need to start here and rotate to here, which is what? 5 pi over 4. I go 5 over 4 plus the halfway rotation. Or I'm memorizing a circle, that's 5 pi over 4. Y'all still don't like trig. We haven't been able to make you as great yet, that way. Alright, so I know the down is 5 pi over 4. So this was drawn almost the same. Alright, so I did all that work to get the formula, basically to get rid of the absolute value. To get rid of the absolute value, I needed to know what are my intervals and which, on each interval, which function is the bigger one. Alright, so this is going to be the integral from pi over 4 to 5 pi over 4 of 2 sine of x minus 2 cosine of x. And then this one is going to be the integral from 5 pi over 4 to 9 pi over 4 of 2 cosine of x minus 2 sine of x. So then I want to simplify this just a little bit. I'd rewrite it this way. So now these switch order, so I bring out a negative sign. And it's still the sine x minus cosine x. Alright, so my integrand is the same both times. I get a negative sign on the outside. Alright, so what is the antiderivative of sine of x?
Negative cosine.
Negative cosine? What is the antiderivative of cosine of x? Sine of x? Plus minus sign, so it would become much harder to think about. You can always check right after. Can I evaluate from pi over 4 to pi over 4? What should I do right now? What's the derivative of this? Derivative of negative cosine is negative sine, the positive sign. Derivative of negative sine is negative cosine. Alright, so this way. Always check right now. It's too easy to miss a negative sign. So. And then what happens over here? It's pretty much the same thing. The antiderivative is the same, right? So I get this. So then what happens? I get 2 times what? What is cosine of pi? Oh, I'll show you that. So it would be negative cosine of pi over 4 minus sine of pi over 4 minus, now I plug in the bottom one, minus cosine of pi over 4 minus sine of pi over 4. So that's the first one. I plug in the top number, plug in the bottom number, and subtract. So this is one I do. That 2 is for everything, so I just put everything in a big curly brace. Delete the 2 outside. And then it's always I plug in, and when I subtract, I put a box around it so I know I need to distribute this thing to sign. So I'm always kind of careful there with how I write this. Mainly I'm trying not to lose negative signs. And then what's the other one? Minus 2 times, now I have to plug in 9 pi over 4. And then subtract and plug in 5 pi over 4. Plug in something pi over 4. What am I always going to get? All these are going to be basically plus or minus root 2 over 2. Because I'm at these pi over 4 angles, I'm always at one of these 2 points on the unit circle, which means cosine and sine are both going to be plus and minus root 2s over 2. So it's some effort. I have all the details written, but this ends up being 8 times root 2. I would expect y'all to show that. I know some of the quiz, some magic. Yeah. No, it was on the prep assignment. On the prep assignment, there was some magic of, I'm going to plug in, hey look, I have an answer, and I don't know, it takes me like half a page to plug in and simplify. Y'all are really good at plugging in and subtracting and doing fractions off the top of your head. It's pretty sad that the halfway point is actually just plugging in. Okay. So again, I posted notes for after class. It'll have all details shown for how to get that number. Any questions on what we did show? So I had one more example I wanted to run through. Times it, 44. Yeah, I just want me to walk you through the solution. I hate looking at solutions done over it. I hate calling it over it. But for 5 minutes, I'm it's a little depressing how long every single one of these takes. I swear the front light switch changes every time I come in here. I don't know how it does it, but they change that every time. It's probably not true. Alright, so the last example I want to look at is find the average value. How do you find the average value of a function? Talked about this real quickly at the end of class the other day.
Take the integral and then divide it by b minus a.
Yep. Find, so average value, the formula was take your definite integral of your function and then divide by b minus a. So it's something you've basically been doing, now you just divide by a number. And it represents the average y-coordinate for your function. So in this problem it said find the average value, so find the average y-coordinate. And then it's guaranteed there's some number that when you plug it in, you get that y-coordinate. Can we find that number? So kind of like for derivatives, it was your average rate of change is the same as your derivative value, your instantaneous rate of change. This says your function has some average y-coordinate, and there must be a number you plug in to get that y-coordinate. Alright, so if I want to find, your book definitely doesn't use this notation, I call it f bar. Why would I do f bar? Is that in chemistry where you put a bar over it to mean average?
Or like the negation.
Yeah, that's for conjugate. Nah, bar in my mind means average. I don't know what class I got that notation from. Oh well. Average value. So this is an average y-coordinate. It is always this formula. 1 over b minus a times your definite integral. So what do I need to do? I'd have to write the function here and plug in the balance. So I find the antiderivative, do all this, lots of arithmetic, and I get 11/3. So it tells me my average y-coordinate for this function on this interval must be 11/3. And then we look at the graph. Does that actually make sense? So I graph my function. And then I drew in a graph of y equal 11/3. How do you know that, or why does this make sense for the answer? The blue part that I'm on top. So I have some area above my average value, and I have some area below my average value. And if it's a true average value, they're the same amount of area. Right. So because this blue part matches this red part in size, that means this truly was the average y-coordinate. Does that make sense visually?
So if you took the area under the average value as a constant function, it would have the same area.
You would get the exact same value as your definite integral. You can take the definite, once you know the average value, the definite integral of the function is the same as the definite integral of that constant value. That's really where the definition is coming from. Alright. So then what's the second part of this? The second part said, now find an input where you get that y-coordinate. So there must be some number that when I plug in c, I get 11/3. If you look at this graph, it happens twice, right? My graph crossed the average value twice. It must cross it at least once. It could cross it more times. Just depends on what your average value is and what your graph looks like. Alright, so I take my y or my function, set it equal to average value. and then try to solve for 0. Thankfully, it's quadratic. So because it's quadratic, I'm going to do the quadratic formula. And this is definitely looking a lot worse than better. And I end up with these two numbers. And it turns out you can plug in either one of these numbers and you get your average value. What's the last part you would need to check? This is my average value on the interval -2 to 2. Both these answers are between -2 and 2. Otherwise, you might have to throw one out. But if you look at the picture, that makes sense, right? -2 and 2, I got 2 y coordinates, or 2 x coordinates, 1 here, 1 here. So that was kind of high level, telling you what the steps were, but definitely look through the details. But the whole idea of average value, in some sense, the formula is too easy. Do what you've been doing, divide by b minus a. But then we go a step further. If you have an average value, there must be some input that gives you that y coordinate. But the whole idea of average value is you could replace your function with that one y coordinate, and in terms of area, they behave the same. So basically, you can do one big rectangle instead of tracking your function as it changes over an interval. Any other questions? Anything? All that will be posted on that learning chart on Canvas.